All right, today's lesson is solving systems of equations by using substitution. We should all know what the word substitution means. It means to replace something with something else. So if I have a substitute as a teacher, they are taking me out of the classroom and we're putting somebody in my place. If you're playing basketball or another sport and you're putting in a substitute, you're taking somebody out and you're plugging another player into his place. So here we are solving for both variables. We have x's and y's in each one of our equations. So we need to solve for what our solution will be. Our solution will be an x, y coordinate. The x always comes first, the y always comes second. So as we solve for them, I'll plug my answer into the solution. Using substitution, you have to have one of your equations has to be solved for either x equals or y equals. Well, it's nice here on problem number 1. This first equation is already solved for y equals. All right, so what I'm going to do is I'm going to substitute all this information into the other y value. And I'm going to use parentheses, and I'm going to substitute all that information in right here. So if y equals 3x minus 8, then I'm going to use this 3x minus 8, and I'm going to substitute it into the y for the other equation. So I'm going to rewrite this second equation to say x plus, I'm not going to say x plus y anymore. I'm plugging 3x minus 8 into his place. And then I'm going to finish that second equation, and I'm going to say equals 4. Okay, and now all I have left to work with are x's. And so I'm going to solve for x. So as I solve for x, there's an invisible 1 here in front of the parentheses. So if I distribute that, I have an x hanging out front. 1 times 3x is positive 3x. 1 times negative 8 is negative 8 equals 4. And I'm solving for x. Combine my like terms here. So 4x's minus 8 equals 4. Let's add 8 so we can isolate our x. And then 4 plus 8 on the right gives us 12. And then finally we will divide by 4 on both sides, and we will get x equals 12 divided by 4, which is 3. The x term always comes first in my solution. So if my x value is 3, now I need to solve for my y. Well, you can use either equation here, either original equation that you want. The easiest one to use is going to be the top equation because it's already set up as y equals. All right, so if my x is 3, then I'm going to plug that in for my x, again using parentheses. So instead of 3 times x minus 8, it's actually 3 times 3 minus 8. So y equals 3 times 3 here gives us 9 minus 8. 9 minus 8 gives us 1. So my y value is 1. So there's my solution, 3, 1. It's an ordered pair. All right, so scroll down. Look at number 4. Number 4, the top equation is not solved for x or y, but the bottom equation is. It's already solved for x, which is nice. So if x equals 3y plus 1, I'm going to take that 3y plus 1 and I'm going to substitute it into the other x value. And again, I'm going to use parentheses. So I'm going to rewrite this top equation since I'm substituting it in. It's not going to be 3 times x anymore. It's going to be 3 times 3y plus 1 minus 5y equals 11. Sorry, I'm filming the lesson. So we'll distribute here to solve for y. Y is the only variable I have left. 3 times 3y gives me 9y. 3 times 1 gives me 3. And I also have my minus 5y hanging out at the end equals 11. Combine the like terms. 9y minus 5y leaves us 4y's. I still have my plus 3 equals 11. Solving for y, so we'll subtract 3 on both sides. And I get 4y equals 8. And when we divide by 4 here to solve for y, we get y equals 2. So my solution here, my y value is 2, so that goes on the right side. So now once I know my y, I need to plug this 2 in to either equation that you choose to solve for x. Well, the best equation to choose is going to be the bottom equation because it's already in x equals. So instead of x equals 3 times y plus 1, it's going to be x equals 3 times 2 plus 1. we do 3 times 2, we get 6 plus 1, so x is going to equal 7. So my solution there is 7, 2. My x is 7, my y was 2. And last problem, number 11. Number 11, neither equation here is solved for x equals or y equals, so it's going to be our responsibility to set up one of those equations to solve for either x or y equals before I can substitute it in. The easiest equation to work with here looks like going to be the bottom equation, and I want to solve this one for y equals. So how would I get the bottom equation to get the y by itself? If this is a negative 6x, we are going to add 6x to both sides. So y is going to equal positive 6x, and I'll move that minus 4 to the end. So now that I have an equation that says y equals, I will substitute this information into the other y value. Again, use parentheses. So when I rewrite that top equation, it'll say 12x minus, it's not going to say 2 times y anymore. It's going to say 2 times, I'm substituting 6x minus 4 in for that y value, equals 8. So now all I have are x's, so we're going to solve for x. 12x, let's distribute, negative 2 times 6x, negative 12x, negative 2 times negative 4, positive 8, equals 8. Like terms, 12x minus 12x, those guys eliminate. So when your variables eliminate, what do I have left? I have an 8 on the left-hand side and an 8 on the right-hand side. When my variables eliminate, are the numbers that I have left true or false? Does 8 equal 8? Yes, that is a true statement. That means we have infinite solutions. If I would have had a false statement here, if this would have said 5 equals 8 or something like that, something that's not true, then we would have no solutions. But since it gives me a true statement, when those variables eliminate, we automatically will have infinite solutions.